Welcome to the topic sparse matrices, and particularly we are going to see about fast transpose algorithm. Before that, we'll start with the introduction of what is a matrix. A matrix is a mathematical object which arises in many physical problems. So generally, a matrix consists of m rows and n columns. So there is two examples for matrix. First matrix consists of 5 rows and 3 columns. The second matrix consists of 6 rows and 6 columns. So this is an example for what a matrix looks like. Now, considering the elements that is present in a matrix, we can calculate the number of elements in the matrix by using the formula m into n. So this gives the number of elements that is present in the matrix. If m value is equal to n, then we can say that the matrix is a square matrix. So it is natural to store a matrix in a two-dimensional array. Say for example, A is a matrix name, and we can store the row values and the column values like 1 is to m, 1 is to n. So this stores the matrix in the two-dimensional array with the name A. And we can get an element from the A matrix by writing the index as A of 1 comma j. So like that we can pick the element from the matrix and we can manipulate the matrix elements. Now, considering the second elements which is given as an example. So in this matrix, we can see that so many zero entries. So if a matrix which contains so many zero entries and very less non-zero entries, we can call such matrix as sparse matrix. So in the example matrix, we can see that out of 36 possible elements, only 8 is non-zero entries. So we can call this matrix as a sparse matrix. So when you are using the sparse matrix, for example, if a matrix is 1000 by 1000, and out of these 1 million possible elements, only 1000 is non-zero. So others are waste of storage, and it only contains only the zero elements. So an alternative representation for sparse matrix is needed. The alternative representation will explicitly store only the non-zero elements. Here in the alternative representation, each element of the matrix is uniquely characteristic by its row and column position, say I comma j. So the matrix values is stored as a list of 3 tuples of the form I comma j comma value. I represents the row value, j represents the column value, and the value represents the non-zero data. It might be helpful to organize this list of 3 tuples in some way, perhaps placing them so that the row numbers are increasing. Thus, the second matrix, which can be stored in an array of A of 0 to T, 1 to 3. So T represents the non-zero terms. So the specified or the given example matrix is represented in the tuple format. Here the A of 0, 1 and A of 0, 2 and A of 0, 3 contains the number of rows, number of columns and the number of non-zero terms respectively. One possible operation on this sparse matrix is to compute the transpose of the matrix. Here the elements are moved so that the element in the I comma j position gets to the j comma I position. It is just an interchanging of rows and columns. The elements on the diagonal will remain unchanged because I is equal to j. So one of the possible operation what we can perform on the sparse matrix, which is represented as a tuple format, is a transpose operation. So here is a matrix A and its tuple representation, and near to that the transpose of the matrix and the transpose of the tuple format. So it is named corresponding as A and B. This is the algorithm for transposing the tuple format sparse matrix, and this algorithm, when it is executed, gets its computing time of big O of n into t. So the algorithm takes more execution time and more storage. So in order to reduce the execution, the fast transpose algorithm is used. The execution time of fast transpose algorithm is big O of n plus t, but with additional storage. So when compared to the execution time of the transpose algorithm, which is previously represented, the fast transpose algorithm's execution time is very less. Now we'll look into the fast transpose algorithm. So this is what the fast transpose algorithm instructions. We'll see the step by step of the algorithm. First, we'll declare the two arrays S and T. Then the number of rows, number of columns, and number of non-zero element of A matrix is copied to the variable m, n, t. In order to do the transpose, n, m, t values are copied to the B matrix in the 0th location. Initially, we'll start with checking whether there is a non-zero elements in the A matrix. So in order to do the check, we'll compare whether T is less than or equal to 0. If so, transpose is not possible. If it is false, we'll move on to the transpose algorithm. So initially, we'll start with the S array. We'll fill the S array into zeros by using the specified for loop. So as you can see, the S array is now filled with 0. All the corresponding locations is filled with 0. Now, based on the column values of the A matrix, the number of non-zero elements in each column is filled in the S array as follows. As you can see in the example matrix, the first column contains 2 non-zero elements. So the first location of the S matrix contains 2. The second column of the A matrix contains only 1 element. So the corresponding S matrix second location has got 1. So likewise, we fill the non-zero elements which is present in the A matrix. The number of non-zero elements that is present in the A matrix is filled in the S array. Next, moving on to the T array, we'll calculate the location of the B matrix where this transpose has to be filled. So in order to do that, first location of the T array is filled with the value 1. The remaining is calculated by using the formula T of I minus 1 plus S of I minus 1. So based on the T array values, the corresponding location of the B matrix will be selected. So here the below for loop will calculate the location, and the corresponding A matrix values will be moved to the B matrix as specified in the for loop instructions. So that's the end of the fast transpose lecture. Thank you.